working on 5. We are working with an inverse variation for x. So notice how this is different. For a direct variation, we had multiplication, where we have an inverse variation now, and we have a divide sign. So something that I'd like you to understand from the direct variation, with our x and y's, with a direct variation, if your x's were increasing in number, so let's say 3, 4, 5, 6, a direct variation, that would be your y's would also be increasing. So 3, let's say, went to 6, 4 went to 8, 5 went to 2, 6 went to 12. There's a direct variation. As your x's increased, so did your y's. They increased as well. Now, what you're going to notice today, the difference is there's inverse variation is going to be a little different. Okay, so let's say we had the same numbers here, x, y, and I had 3 for my x. I would have, let's say my y would be, 2/3. 4 would give you 2/4. 5 would give you 2/5. And 6 would be 2/6, which is the same as 1/3, 1/2. So notice, as my x's are increasing, they're getting bigger, my y's are actually decreasing, they're getting smaller. So that's why it's an inverse variation, where here these were getting bigger, and these, your y's, were getting bigger as well. So the difference between a direct variation, they're both getting bigger, where inverse, one's getting bigger and the other one's getting smaller. So let's go to my next. Suppose y varies inversely with x in a point on the graph of the equation 8, 9. Write an equation for the inverse. So we're going to use this general equation here. X times y equals your k, or the other way would be y equals k over x. And we're going to substitute. So we take and substitute from our initial. X is 8, y is 9. So plug them straight into to find your k, your constant. 72 is my k. So to rewrite the equation, and make sure you do not leave it as k equals 72. You do have to rewrite it and make sure you include your x and y. So x times y equals 72. So once again, this is just saying your inverse variation is including your x and y, and we want to leave it as y equals. So y equals 72 over x. So you're trying to see if a point is on the graph. So is 8, 9 on the graph of this equation? Yes, it is. Okay, the next one. The point 5, 6, and 3y are 2 points on the graph of the inverse variation. Find the missing value. So to find that, this is what we're going to use. We're going to do x1 value times y1 value equals x2 value times y2. Because you know the coordinates but not the constant, we're going to solve and try to find this y, this missing value. So plug in what we know. We know 5. 5 here is my x1, y1, x2, y2. So x1 we said was 5 times your y1, which was 6. x2 is 3. y2 is the unknown, so we kept it as y2. Solve. 5 times 6 gives you 30. 3y. We're going to divide by 3 here, and 10 equals y2. Now that we know 10 is equal to y2, we know that 310 is this point. So our graph, our inverse variation includes the point 56 and 310. Example 3, a 220-pound weight is placed 5 feet from a fulcrum. How far from the fulcrum should an 8-pound weight be placed to balance the lever? So figuring out what we know here. A weight of 120 is 5 feet. A weight of 80 pounds is unknown. We're trying to figure out where to place this 80 pounds at. Okay, so we're trying to keep this balanced. So think of it here. We're trying to keep it balanced. We need to know where we should place this little guy to keep 120 and 80 pounds balanced. So weight 1 was 120, weight 2 was 80. Our distance for weight 1 was 5 feet. Distance for 2 is what we are trying to find. So we're going to leave that as our unknown. We're going to use weight times distance equals weight times distance. So keeping things equal. Substitute what you know. 120 times 5 equals 80 times x. Where did I get 120? Well, 120 is the weight of 1. Distance 5 is the distance for 1. Weight 2 was 80 pounds, and the unknown distance we left as x. We're going to solve. 120 times 5 is 600 equals 80x. We're going to divide by 80. So x equals 7.5. So the weight should place 7.5 feet to balance the lever. Example 4. Decide if each data set represents a direct variation or an inverse variation. So this is what I started getting into at the beginning of the lesson. What do we know? 3, 5, 10. My x's are getting bigger. My y's are getting smaller. So we know with our y equals k times x, this is the direct. We were constantly getting straight lines with this form here, with our direct variation, because as x was getting bigger, so was your y. Okay, but now my x is getting bigger, so my x values are going to be getting bigger, but my y values are actually getting smaller. So my first one's going to be up here because it's bigger, but now my y values are continuing to decrease. Okay, so your graph here for an inverse variation is going to look something like this, where your direct was a straight line because they were both getting bigger. Now my x's are getting bigger, but as my x is getting bigger here, my y values, the biggest one is here, and your smaller y's are here. So as your x's are getting bigger, your y's are getting smaller. That's what this table is showing. So we know, it seems like y is varying inversely with the value. So we know it's an inverse variation. So let's check it. We know x times y equals my k, so let's find my k. 3 times 10 equals 30. 5 times 6 equals 30. 10 times 3 equals 30. So what's my k value? Well, we found k. K is 30. So as you can see, k is 30 the whole entire time. So k is constant, and it's an inverse variation, and k is 30. So to rewrite this, because like I said, we do not want to leave it as k equals 30, plug it back. X times y equals 30. So then divide by x, y equals 30 over x is your inverse variation equation. My next example, example B here. So my x's, let's just take an observation. What do we see? X's is going from 2, 4 to 8. X is getting bigger. And as my x gets bigger, y is getting bigger as well. So let's draw something what that look like. As my x's are getting bigger, my y's are getting bigger. So I know that's going to create my straight line, somewhat straight. So I know this is a direct variation. So let's take a closer look. Plug it in. I know my direct variation is y equals k times x. To find k, you divide by x. Y equals k divided by x equals, let's try that again. Y divided by x equals your k. So 3 divided by 2, 6 divided by 4, 12 divided by 8. You can see what's happening. You're getting 1.5 every single time. So because these are constant, we know k equals 1.5, and it's a direct variation. So plug it back in, like I said before. You can't leave it as k equals 1.5. Plug it back into y equals. Plug your 1.5 in for your k, and there you have your direct variation equation. Example 5 here. Explain whether each situation represents a direct variation or an inverse. So you buy several souvenirs for $10 each. What do you think? Write down if you think it's a direct or an inverse. The cost per souvenir times the number of souvenirs equals the total. So cost over souvenirs is constant at $10 each. This is a direct variation. So you buy several souvenirs. So what will that look like? If I buy one souvenir, I know it's going to cost me $10. I buy 2 souvenirs, it's going to cost me $20. 3 souvenirs is going to cost me $30. Do you see here how we're creating a straight line, and it's a direct variation? It is following the y equals k times x formula. Let's take a look at example 5b. The cost of a $25 birthday present is split amongst several friends. So write whether this is going to be a direct or an inverse and explain why. Alright, let's take a look. I know the cost is $25 total. If I split it amongst just myself with no friends, let's say, I know it's going to cost me $25. But if I split this present between me and my other friend, it's going to cost me $12.50. Okay? Now, if I split this even amongst 4 people total, it's going to be $6.25. If I can split this amongst 5 people, it's going to cost $5. Oops. Now, let's say I do it even amongst 10 people. 1, 2, 3, 4, 5. It's going to cost us roughly 2 something. So it's going to be way down here. My dots have vanished on me, but we're getting this look. This is an inverse variation here, because as your x's are increasing or getting bigger, my y value is getting smaller. Alright, go ahead and work on your practice problems.